This is the video to give the demo on digital experiments. So in digital experiments, you have two types. One is behavioral modeling. Another one is Verilog program written in by using switching circuits. So only the switch level modeling. Okay. So in switch level modeling, you can do only till simulation, and for behavioral modeling or gate level modeling, you should do till synthesis. Okay. So I will show you the procedure for that. First, open terminal. After that, so first source your cadence tool. The procedure for that is press CSH. That will open the C shell. After that, press source /home/install/CSHRC. So you will get this. You will get like this. It is welcome to cadence tool. So in this, you create a directory. For creating a directory, the command is mkdir. So you can type mkdir and you can give any folder name. I will give it as VLSI lab, or I will give it as Deepak. Okay, you should create your folder with your name or with your USN. So already my folder is there, so it is showing that folder already exists. Okay, so after that, get into that folder. To go into that folder, the command is cd your folder name. So my folder name here is Deepak. So cd Deepak. Okay, now the control is in your folder. Right, you can see here it is control is in your folder. So in your folder, create a file to type your Verilog program. Create a file to type Verilog program. I will create a file gedit. The editor name is gedit inv.v. So if I type gedit inv.v, you will create a file to type your program. Okay. If you press yes, that file will be opened, and you should type a program here. You should type your Verilog program. So after typing your Verilog program, you press save. Already I have typed it. Okay, but you have to type your Verilog program here. After that, press save and close it. After press save and close it. So next you have to type your test bench program. For that, gedit invt.v. You can type like this, gedit invt.v, and press enter. Again, another editor window will open. In that, you can type your test bench program. So after typing your test bench program, press save and close it. Okay, you have typed your Verilog program and test bench program. So both you have to compile for errors. For compiling for errors, the command is ncvlog file name, that is inv.v. That is the first file, right? inv.v, and minus mess. So minus mess will give you the message. Okay, press enter. So you should get like this: 0 errors and 0 warnings. Similarly, compile your test bench file. The command for that is ncv log invt.v minus message. So ncv log is a command for compiling. invt.v is your test bench file name. It is a file name, and minus message is the thing which you're typing to get the message. So press enter and you should get 0 errors, 0 warnings. So after this, after compiling, you should elaborate. So for elaborating, what is the meaning of elaborating? Means you will combine both the files, your test file and your main Verilog file. Both the files you are going to combine. After that, you can simulate it. So the command for elaborating is nce lab module name. This is the module name. nce lab. Now you have to type the module name. So module name of inv.v. First I will show you what is a module name. Okay. I will open that again. Gedit, the program which I have written, right? I am going to open that back. inv.v. If I press enter, the program which I have written already, that will be open. The module name for that is inv. Module name for inverter program I have given as inv. And module name for test bench, I will open that again. To open that, type again gedit filename.v. That will be opened again. Okay, you will get again module name inv.v. You will get inv T. This is the module name. Okay. After seeing the module name, next is you have to elaborate. You can do NCE lab module name. First I will elaborate INV. Okay. First I will elaborate INV minus access plus read write read write control. NCE lab module name minus access read write control minus message. So the elaborating has been done, right? Similarly, you have to elaborate your test bench also. The command is nclab invt. Invt is the module name of the test bench. It is not the file name. It is a module name. Invt minus access plus read write control. RWC is short form for read write control minus message. Okay. Press enter. So both has been elaborated. So after that, you can open your simulator to see the test bench waveform. The simulator is nc sim minus test bench module name you have to give. You should give here only the test bench module name, not your program module name, because you are simulating your test bench. You should give your test bench module name minus GUI. NCSIM INVT space minus GUI. So if you press enter, the test bench will open now. So it will take some time, and SimVision or NCSIM test bench will open. The software will open now. So after this cadence, look at what's new window will open, close this, it is not required. After this, select on this INVT, select this both pins by holding control, select this both pins by holding control, and select on this waveform button. After getting this waveform, after getting this window, in this window, you can see this run button. So side to this run button, you have a black arrow mark pointing downwards. Click on that and give the timing. See, you can give timing as per your test bench. You can give the timing as per your test bench, but here I will give it as 40 nano. You can give timing as per your test bench. Here I will give it as 40 nano, and I will click on run button. And you can see the output waveform. This is an inverter. When input is 0, output is 1. If I click here, when input is 1, output is 0. If I click here, when input is 0, output is 1. So this is the simulation. This is a procedure for simulation. This we have to, this only till this you have to do for switch level modeling. Okay. Till for switch level modeling, you can do only till simulation. So next we will see how to do synthesis. This you should do for gate level modeling also. So you can close all the windows which you have opened for simulation. Everything you can close. Okay. So after this, you type genus. See, genus is a tool for synthesis. Genus is a tool for synthesis what we are using. Type genus space minus GUI. Genus space minus GUI. Genus is a tool for synthesis. GUI stands for graphical user interface. The graphical user interface tool will also open. After pressing enter, so this window will open, genus GUI window, and in terminal you can see that genus colon root or genus colon student you will be getting. you will get like this. Okay, you will get like this. After this, after doing this, you type, you have a file, that file called as, see, I will open my folder, the folder which I have created it. I created the folder in name of Deepak. So in this folder there should be three files. One is constraint.sdc. This file should be there, constraint.sdc, synthesis.tcl. So your lab instructors or your faculty will give these files, constraint.sdc, synthesis.tcl, and these two files should be there. And obviously in your folder there will be inv.v, right? There will be inv.v. Okay. These three files should be there in your folder compulsory. Constraint.htc, in this file you have to constraint.htc, you can open this. To open that, I will open terminal, I will open gedit constraints.sdc. So here by typing gedit means it is editor, constraint.htc is a file name. If you click this, this constraint.htc file will open. This constraint.htc file will open. You have to, here you have to type the constraints. Here you have to type the constraint commands. Okay. Here I have to type two commands. That is, input delay is 1 nanosecond and output delay is 1 nanosecond. So before coming to the input pin, the delay is 1 nanosecond. From the output pin, if it is going to next circuit, then the delay is 1 nanosecond. So the two commands I have typed here, the set input delay, maximum delay is 1 nanosecond. Output delay, maximum delay is 1 nanosecond. So input port is A and output port is B. This I have already typed. This constraint file will change for program to program. That we will tell you how to edit it. Okay. While doing individual program, we'll tell you how to edit it. So in constraint program, you will be having a constraints. Synopsis design constraint commands will be there. So you can open that by typing gedit constraint.stc in separate terminal. You can open separate terminal. You can type this. You can open this file and you can change the contents of that. And there should be another file called as synthesis.tcl that your lab instructors or faculties will give you, and your program inv.v that you have already typed. So after that you can go back to your terminal window. Here you can do only one thing, source synthesis dot tcl. You type synthesis dot tcl and press enter. Okay, there is some problem in this file. I will change it. This, okay, this, it is showing there is a line. This is not required. So you can go back to your window and you can type that command, source synthesis.tcl, and press enter. Okay, now synthesis has been done. Now synthesis has been done. You can go to the GUI window. So at last you can type GUI underscore show. After that you can type GUI underscore show and press enter, and you can go to this GUI window. Okay, this GUI window, you can see the cell. So right click here, you right click here, schematic in main. You right click on this view cell. You can see schematic view, right? You can select in main. You can see the inverter. The cell what it is used is INVXL. Okay. So this is a procedure for synthesis. Only thing what you have to do is you have to type source synthesis.pickle. Only this you have to type. Then after that you can type GUI underscore show. Then you can see the at right side you can see this hierarchical cell INV. Okay. You can right click this and in schematic you can click on in main. You can see this. Okay. So after this, so don't close this. After this, you can type report timing, report underscore timing, TIMING minus unconstrained. Report underscore timing minus unconstrained to see the timing report. So here there are two designs. So I'm not getting the timing report. So you can see the timing report. This is the timing report. Here already you have so already you have in that already you have given 1001 nanosecond delay or 1000 microseconds, 1000 picoseconds delay. 1 nanosecond is equal to 1000 picoseconds. So that much delay it is showing at the input pin, and cell is going to give another delay of 12 picoseconds. The total delay is 1012 picoseconds. Next, you can type report area for area report. This is the area report. Next, you can type report power for power report. This is the power report. You will get leakage power, dynamic power, and total power. You know what is leakage power? It is due to static power dissipation or direct connection between VDD and ground. Dynamic power is for charging and discharging the capacitance, parasitic capacitances. Total power is sum of these two things. Dynamic power is due to charging and discharging the capacitance. Total power is sum of these two things. So this is a procedure for synthesis.